Hello and welcome. We're going to take a look at symmetric equations of a line in 3D. Recall that so far we have looked at the vector equation of a line in 3D, which is xyz. xyz represents the coordinates of any point on the line, equals x0, y0, z0. These are the coordinates of a starting point on a line, plus some multiplier t that multiplies a, b, c, where a, b, and c are the x, y, and z coordinates of the direction vector. Based on the vector equation, we created parametric equations, which are nothing but special equations for each coordinate. So we said x equals x0 plus ta. That's a parametric equation for x. And then in the same way, y equals y0 plus tb. And then z equals z0 plus tc. So the parametric equation for z. Now, in this lesson, we are going to learn how to build what we call symmetric equations. Symmetric equations are built based on parametric equations. So we are solving each parametric equation for t. And you can tell I'm just going to do the first one. So x minus x0 would equal ta. And if you want to isolate t from a, you divide both sides by a and you get x minus x0 over a equals t. In a similar way, we get t from the second parametric equation as y minus y0 over b, z minus z0 over c. So now you're probably wondering, why are we adding more equations? So what is the benefit to using so many of them? It's always great to look at things from different perspectives, and symmetric equations in a way can help us identify the direction vector, right away. We can spot it from the denominator, and it helps us solve a lot of problems more easily. But for now, we're just going to learn how to create them, how to build them. Here we have the first example for A. We have to write the symmetric equations of a line that passes through these 2 points. So if I want to know the symmetric equations or create a symmetric equation, I'm going to need to know the starting point, x0, y0, z0. And for this, we can use any of the given points. And in this case, I prefer to use point A. And I'm going to say -1, 5, and 7 will be my x0, y0, z0. Next, we're going to need the coordinates of a direction vector. And a direction vector can be actually the exact vector that connects A and B. So I'm going to say it will follow AB because the line has to pass through the points. Now remember that it can be vector AB or any multiple of vector AB. So we're going to say that this would be 3 minus -1. So remember always from B to A. So 3 minus -1, that's a 4. Next, -4 minus 5, that's a -9. Oops, different color. And next, we have the z coordinate, 8 minus 7, that's a 1. So there we go, we got starting and direction vector, which means that we have x0, y0, z0, and we have A and B and C. Let's build the equation. So we have x minus x0, so minus -1, divided by A. Remember that A would be the x-coordinate of direction vector, equals y minus 5, that's the y0, divided by the y-coordinate of the direction vector, which is -9, and then equals z minus +7 divided by 1. So in a more simplified form, then we're going to say that this equation can also be written as x plus 1 over 4 equals y minus 5 over -9 equals z minus 7 over 1. And voila, this is the symmetric equation of this line. Now, in the next question, we have to write symmetric equations of a line passing through these 2 particular points. And I've actually added this as practice for you, but I'm going to do just this example. So let's take a look at it. So again, we are going to start off with picking one of the points as our starting vector. X0, Y0, Z0 in this case will be, let's choose point Q this time. So -4, 3, and -5. So for direction vector here, we're going to choose the direction of vector PQ. So here I go again, -4 minus -2, that would be -2. And here we have 3 minus 3, that would be 0. And last we'll have -5 minus 1, so that's -6. So let's create the equations. So we have x minus -4. Divide this by a, which is -2. Remember, this is a, this is b, this is c. And again, just to emphasize, one more time. And then we have y minus +3 over 0. Oops. So we're going to talk about this. And z minus -5, and then divided by -6. So let's simplify this. So we are going to say that we have x minus -4, that's x plus 4 over -2. Now, as you can see here, this makes no sense because y minus 3 divided by 0 is undefined. So we're going to leave it aside for now. And I will write z plus 5 over -6. So something needs to be done about this. So we cannot show a 0 in the denominator and put it in a formula. So in the meantime, though, we cannot deny the fact that this is an existent, actually, direction vector. And this 0 actually is what brought the problems in. So we are going to say that for this particular vector, all we know about y is that it equals 3. And it won't depend on the y coordinate of the direction vector. So we're going to write a comma here, and we'll write y equals 3. And with this, we're going to complete our symmetric equation. Now, you probably wonder, what happens if we actually end up with having, let's say, z equals a number, right? I want you to think about it and ask these questions in class. Thank you for watching, and bye for now.